Welcome to the Scicloj web meeting number 9. Scicloj is a community initiative to promote scientific programming with Clojure. And we are doing these web meetings as a means of achieving that goal. For those of us who use the tools that others create, when we can join and learn something. And for those that create the tools, we hope to give them good feedback and an understanding of user challenges. My name is Theodor Heggelund. I'm a Clojure programmer, and I've found programming useful in civil engineering. Today, we will hear from Tommi Reiman. You might know Tommi from Reitit, a routing framework, or as a Metosin co-founder. Metosin recently sponsored the Clojure conference in Finland, or from his work at making Clojure go fast. Today, he will be speaking about Malli. But before we get started, I have a bit more information to give. I want to inform everyone that this meeting will be recorded and the recording will be released on YouTube, publicly available. So you know that if you ask any questions. If you're able to, I would like to ask anyone to turn on the camera. That makes it a lot simpler to present, and Tommi will be able to see you if you ask questions or see if you really like something or if you don't understand something. Presentation, then feel free to interrupt and ask them. If you don't want to interrupt, then you can either ask me to interrupt in the chat. I hope everyone can see the chats. I just wrote hello in the chat, so you should be able to see that. And if you don't want to speak, then you can just ask your question and I can read it to Tommi when that is appropriate to do. I would also like to ask everyone to mute their microphone when they're not speaking. That way we avoid background noise and it's easier to hear what's being said. And there's a button for that on the lower left corner of your Zoom window. Today's agenda is that Tommi will show us Malli, and then we will open for discussion. And the meeting will take approximately 2 hours. And the first part will be more with Tommi's rhythm. And when Tommi has gone through the things that he wants to go through, then we'll open for broader questions, I think. So that's everything that I'm going to say for now. Tommi, please take the stage.
So thanks for the introductions and thanks for having me. It's like an honor to be here presenting the Malli. So I'm from Finland and it started to snow today. So we have winter here, which is awesome. But like, about the background, so I think we have been doing Clojure for 7 years, and before that I was doing a lot of Scala and Java development, and I remember in the Java days we had the same problems. So we were doing these dynamic forms and dynamic models, and those days it was XML, and I recall writing at least 2 libraries. They were not open source libraries, but trying to solve the same thing. So some kind of dynamic data models with dynamic rules. There was groovy sandboxes running these like source code from company forms. But when I started to do Clojure and the Clojure like promise of everything is data, it was like an eye-opener that the things I was doing in Java with those enterprise technologies, they are like really simple in Clojure. But before today, I haven't seen like, there's so many libraries, but and they have really good features, but for some reason we have been doing these reinventing these data-driven form libraries or schema libraries, and we have like several of those within the projects. And we decided, let's do something for that, and let's try to write one library which would be good enough for those projects we have been doing in Clojure, but also based on those requirements which we have, like in the previous life. But I'll start sharing, if that works. And if you have any questions, I'm happy to answer them immediately or afterwards. Let's see if we can. Can you see my screen?
Yes.
Awesome. So usually I have slide set deck which is like 100 slides, but today I thought that I will do no slides. I have only the repl with cursive and all the stuff is in here. So let's start. I have this namespace called Malli.sky. How do you pronounce it? Scicloj. But and for today's presentation. So the library I'm going to talk about is Malli. And Malli means a model in English. Try to move that away. So it's in GitHub. It's quite new. It started like 4 months ago. And the value proposition is this, that everything is data basically. So there are no macros in the library. You can use functions, but basically there's this hiccup syntax for defining everything. And because of that, you can persist the schema definitions, put them over wire, put them to the database, and like read them in the Clojurescript. But it started like just a test that, because we did the routing library, which had similar like design principles. So that let's try to take this hiccup syntax and do a modeling library on top of that. And just like feature by feature, doing stuff and seeing what comes up. It's still pre-alpha. I'm surprised that like it was posted in, I think, Devon some months ago, and it was like picked up, and there are many users, many contributors. I'm really happy for that, but it's like not finished yet. And we want to like not freeze there are many open design decisions, and we haven't wanted to like lock them yet, because there's so many things we have to first do and see that after they're done, we can optimize the whole and see what kind of package will come out, but hopefully within this year. The motivation, let's go there. Actually, it's in the README. And there are already really good libraries in the Clojure space. The schema was, I think it was 2014. It came out, the prismatic schema, nowadays Plummatic schema. And I'm still using that in the project. So the project, which is about to end actually tomorrow, it has schema there because it was the most robust solution we could pick up for that. And when the project started, Clojure spec was not finished. It's still in alpha, and we are leaving from the project. So we didn't want to leave anything like alpha there, because spec 2 is coming and it might change everything, and we are not there to fix it afterwards. So schema is great, but it's not meant for serializing data. So it has records, and there are a few efforts of making these transit schemas, but they are not actually really working. And another thing is that, like when you have these or and tracks and schemas, you are not having any backtracking of those, but it's still good. And whenever there's a bug in schema, it's usually fixed within few days, so it's still like maintained. There isn't any active like development, but still any bugs are fixed really fast. Then there's spec. We also use that in many of the projects, and like but it's still alpha, and there's some few things that like I haven't been that fond of, and it seems that spec 2 is fixing most of the things. So Alex is doing great work there, putting the like schemas, specs as data, and this transformation between the current syntax and the like data syntax. But one thing which is missing from there is the runtime transformations. It's the coercion basically, and like it's not in the scope. It will never come. And we did this library called spec tools to try to fix that. But it's full of hacks, and it have to be rewritten partially when spec 2 comes out, and there's no schedule for spec 2. So just we wanted to do something and start playing with ideas, and so we spinned out this new library called Malli. And like there's an online playground. Let's look it in the end, but let's start evaluating things. So in Malli, there's this core namespace, Malli core. Let's require that. And then what we can do is we can validate data. And the validate, it takes schema and a value. So this is a schema. Actually, it's schema AST. Then we have the value. And then we could have the options. They can be empty. But all these top-level functions, they either take a valid schema object or they take the schema AST and convert them into schema. So if you use schema AST, it's a bit slower, but it still works. It's kind of nice. But that's the core idea. You have these data structures, which are the schema definitions, and you do something with that. And how the library is organized, it has the main namespace called malli.core. It's standalone. Their only dependency is the SCI, and it will be made optional dependency. And then there's these sub namespaces which you don't have to use. And I think the core is something like less than 10 kilobytes zipped in the JavaScript side. So it's pretty small. The transformations, they are in one namespace. It has like from Plamatic schema, string and JSON transformation. It's quite small also. There's serialization using the Borgdude's edamame. It's also small. It just like writes the schemas to Eden and reads them back with few reader tags. Human errors, we wanted to test that too. So it's like one monorepo at the moment, and all the like concerns are different namespaces. It might end up being that this like a multi-module library, but now it's like just basically one a separate namespaces. And if you only use the Malli core, you don't get any extra dependencies except the SCI. If you use Eden, you get the edamame. If you use generator, you get a test check and test chuck, and so on. Malli provider, it's this F# style type provider kind of functionality, same as in spec has the spec provider. And as you can, these are the lines of code. So the extensions are really small. So because the core, because we wanted to optimize the whole, so we pushed enough hooks to the core so that it's easy to build these kind of extra applications. And JSON schema transformation, so for Malli schemas to JSON schema to Swagger, also really small. There will be few extra namespaces for visualization, etc. But idea, small core, enough extensions, and we are not locking the library because we are not sure which extensions. Extension points are still needed. Some public APIs and one dependency. So what do the schemas look like? The simplest schema is an like core function. When we evaluate that, it evaluates itself, so it's just the function value. All the core functions have like two presentations. One is the like value format, and another one is the unqualified symbol. And both are registered, and it allows us to go from one form to another. So in the Eden format, we see the like this form, and when we read it from Eden, we convert it into this format. So there's a mapping table. So from this function maps to this symbol. If we want to do something more, so we use the hiccup syntax. So first, it uses vectors. So we have a vector, and the first element is the name of the element, and then there are arguments. And here we have a tuple, which is double. And again, it's just data, so it evaluates to itself. They can have properties like hiccup. So here we have a property map with title, location, double. We can compose things. We can have this and. We can say that something is an integer and it's greater than 18. We could have or. We could say that it's an integer or it is a string. Spec has these named branches, and Malli doesn't have any of that. So I think that Spec is awesome for doing like this development time, like tooling, and in runtime, Malli is optimized for like runtime schemas. So we have the branching information, but they're like derived. So this would be the branch 0, and this would be branch 1, this would be branch 2. So they automatically generated. There's an enumeration, maybe. So there's the maybe not thing with spec, but like it seems to be that in many real life systems, like nillable is a fact. For example, there's many like JSON schema, it can have nil and JSON can have nil. So we just wanted to support that too. You can have regexps. There's this way of the schema expander has this type-based shortcut, so the regexp can be given in the normal form. Then you can have custom functions, so anything that is a function can be used. But if you use functions, so spec is good for this because it has this these macros which capture both the source code and the like. Based on that, they can use the value. But in Malli, there are no macros, so if you would evaluate this, we can see that there's some like function, and we have no idea what is the source. What good thing is that if we want to make portable function, we just quote that, and what we capture is the source code, and SCI, the library, we can evaluate that at runtime. And that also works in Clojurescript. So if you have a schema which has the function and you put it over wired Clojurescript without eval, you can like run it over there too. There are collections, vectors, lists, sets, and then there are maps. And map has this bit different syntax. So all the elements, the parser first delegates it to this like map schema definition, and it knows how to parse its childs. And in maps, there's like vectors of these childs. So this is a map of X and Y, and both are ints. And this is like, let's evaluate that. And this is like a bit larger schema. So we have and we can have some metadata title. First element of the and is a map. It has X and Y, and an address, which is a submap. It has a street, which is a string, city, which is optional key. Also, the optionality is like supported. And the city is Helsinki or Tampere, and the location is a tuple. And then another element for the and is a function schema. It has this error message. So one of the goals was to get these like error messages right, both for developers and for end users. So here we have defined this error message, and then a function schema that it gets the value of the first element in the and checks that X is greater than Y. But again, this is just data, and like now there are the functions used in here, and we can see that like you cannot put this over wire. But if we would say that, let's write a schema out of that, we would see the form. So actually this is what goes over the wire. So all the like functions, there's this registry which maps from function to the simple symbols. So you can put this over wire. Yep. And like how it's implemented, there are two protocols. There's this into schema and schema. And let's go to see the definitions. Into schema is something that takes the AST and creates the schema object out of that. And the schema object looks a bit like spec object, actually a lot. And we can ask the name of that. We can create validator out of that, explainer out of that, explaining also coming from spec. Big thanks to Rich and everybody else who have been doing that. We have a transformer. This is the thing that I would have wanted to have in spec. So the value transformation, and then schema walking, this generic extension point, most of the features built on top of that. This, you can ask properties and you can ask the form of that. those are the two schemas. And if we check like an example, this maybe implementation, they are like quite simple and bit like the spec implementation in Clojurescript. So maybe schema, we reify this into schema, which takes the like AST. So this was like given. We check that it must have only one child, otherwise it fails. We create in like check the first schema. We create a validator out of that. We create a form for that, and then we return this reified schema. And its name is maybe. It has a validator, explainer, transformer, accept properties, and form. And that's about it. Any questions so far? Let's see. I guess no.
I actually have a question, if you don't mind.
Yep.
Is Malli based on any of the other schema libraries, or is it totally built from the ground?
No, actually, it's built on everything else. So here's a list of thanks. And I think that it has some own ideas, but most of the things have been reinvented earlier. So big thanks to Schema. The coercion stuff is basically, we have been using Schema coercion for like 5 years. Clojurescript, it has lots of brilliant ideas explaining the errors as data. And core type, just like source of innovation in many ways, the union types. TypeScript, the thing that I know about it, I like been looking for that. Scicloj, JSON schema, spec provider, and F# type provider. So I would say that it's like a fusion of the best features in the libraries and adding something on top of that. And of course, the like way of we will trade it, the performance and the like structuring of things. So it's a combination of those. But I think the end result is something that I haven't seen earlier. So it's like JSON schema, but idiomatic closure as Eden. So I think it's cool, but good question.
Just a small follow-up. Does that mean inside of Malli there's no dependency on schema or spec or anything?
No, okay. No. I can show the dependencies. So deps Eden. So what it has is it uses Clojure. I started to use deps just some time ago. I'm not sure, do I have to depend on that directly? It uses the SCI. It's the only like core dependency. If you want to use the serialization, you use Edamame. And then like for the generators, it uses test check and test chuck. And again, if you don't need the generation, you don't have to have them. Probably this will be split into few dependencies that if you just take the Malli core, you just get the SCI.
Okay, thank you.
Okay, so the public API, let's walk that through quickly. So we have a schema AST. It is an AND which has some properties. It's integer which should be greater than 18. And when we evaluate that, as we saw, like the raw form is just what you gave it. So the int question mark is still in the value form. You cannot serialize that. But when you run a schema for that, the schema is constructed and the form does the lookup, and for all the registered predicates, it finds the symbol. And the form is basically the same. So actually the print out, what comes out from the printer, it is the M form. So if you ask type for this, type, it's actually a schema reified protocol, but there's the print method overridden, so it looks like this. You can ask the properties, that's simple. You can validate that. So 1 is not for correct for the schema. 20 is because it's over 18. I'll put this bigger. And then performance-wise, in the schema, there was this validator, which is basically building optimized validation function for the given use case. And when we call validate, the validate actually creates its validator for the schema and calls it once and throws that away. So it's like convenient, but not that performant. If you want to have performant version, you create this validator, and after that you have this pure function which does the one thing, and it's as light as possible. Explain. Thank you, Clojure spec. So I think the programmatic errors in spec are awesome. And in schema, in Malli, there are the similar. So what we get out of this error, we see that the schema which failed was this, and the value we gave was 1, and the error is in path 3, and which means that it's the index, so 0, 1, 2, 3. So this one failed, and the value is the top form, and this is the failing schema, and this is the value. So lots of information, all the information that is available at that given time. And when we explain 20, it says that no errors basically. And same here, optimized explain. You can take the explainer, and for example in rated, when we do coercion, it will get a transformer ahead of time, and in request time do as little as possible. And then there's the one thing that I wrote issue to spec some years ago. It was the generic walker. I'm still would be happy to contribute that in here. This is how it works. So all the spec, there's this accept method function in the protocol, and you can just say that take this AST and walk that, and for each element there is like return it as vector. So this was like Clojure walk basically, top level thing, like then the next things, and then the last elements. So that's nice, and all the JSON schema things built on top of this. Registry. So what are available? What kind of predicates and schemas out of the box? Here's the list of all the things that are possible. The default registry, which is used by all the top level functions, it's a merge of this predicate registry, class, comparator, and base. And in the predicate, we have listed the things from Clojure core, the core predicates which seemed useful. It's about the same list as in Clojure spec. There might be small differences. But we have this helper that we register both the symbol form and the function form. In class, there's this regexp. So if you are giving something which is of class regexp, that is used. For comparators, there's this greater than, greater and equals, not equals, so on. And the base thing is the list of extra things, and or map of vector, list, set, enum, maybe tuple, regex, and function. They are separately here because if you want to make your own registry, you just say that my registry, if you don't like these, for example, you can say that drop those, but only take these class, comparator, and base registry. And when you have the registry, you can pass it into the top level function and say that these are my specs, no schemas. And if you want to have sorry for jumping. So there's in the README is at the moment the source of all the things. So custom registry, here's an example. If you want to have, for example, you don't want to use those predicates, you want to have these keyword schema. So int would be a function schema of int, and its symbol would, function would be, a predicate would be int. You can add your own stuff, add your domain stuff, and after that, they are available. And because you didn't put the normal predicate registry, it's not available. There are guides also. Spec has this mutable registry, which is easy. There's no such thing in Malli, but you can have that. So you can have an atom of default registry and this function which adds something to that. And then you can say that register bang, let's have this ID which is int, and let's have this name which is string, and after that they work. And if you just deref that when you need it. And there's also, if you want really mutable, this is, I don't know the alter var root. I think it's, don't ever use this kind of thing. But evil registry, you don't have to even pass anything. You just mutate the default registry. But I think that this would be valid. So if you like this spectile way of registering things wherever you need them, you can do that. But the registry is explicit in the sense that whatever is passed to the function is used. And by default, that's not you cannot mutate that. Transforming values. So if you have used a prismatic schema, you should know how this works. And actually in spec tools, we added this two-way transformation. So you have different pipeline for encoding and decoding, and there's a pull request for adding that to Malli too. So we will copy paste from our own library too. But this means that when you have a value and you have a schema and you have this transformation context, let's say that JSON, you will get this transformation functionality that this schema, what was the schema, by the way? Schema. Oh, it was the AND thing. So if we give this string 1 and say that it came from JSON, it doesn't do anything. But if we say that it came from the domain of strings, it will transform that. Because if it's, for example, a properties files, in property files you cannot present numbers, they're all strings. In JSON you can do numbers, so we are not converting those. And same, for example, if you want to do keyword, that there's like schema would be keyword, and we would have something like kikka. Like it will be transformed in both of the JSON and string, because you cannot have keywords in JSON, so we have to apply the transformation. But if there's nothing to do, it does nothing. And the change will be, let's see that also. I did yesterday, so that you can add the decoding and encoding hints to the schemas themselves. And this is from spec tools, and the people were wanting to do this. And you can easily create these new things, for example, Joda datetime or whatever, and say that I have this datetime kind of thing, and I will describe with schema properties how it flows through different domains. Another thing, another concern, these humanized errors. This is something that I was studying a lot, because I wasn't sure that there's like a really good solution anywhere. I was looking for the JavaScript libraries, the Clojure libraries. There's phrase for Clojure spec. I think that's good. But like in the JavaScript side, there were all these conventions of how to do localization. So this is like a mixture of everything. So Malli error. And if we do a basic explain for this kind of data structure, so we have a map X and Y, and we explain something that X is a string and there's no Y. So what it gives is two errors, basically. It says that in path 1, 1, which is like 1, 1, this one, and it is a schema pointer, there's something wrong, and the schema is int, and in the value it's X, so meaning this one, and the value was 1. So that's not correct. And another one is that Y was missing key. But this is like good for programs. If you want good for humans, we will run this with error messages. And what comes out, it attaches to those errors a humanized string of what is the cause. So missing required key and should be int. And if we want like this is something that we could, for example, send over wire to the user. This is what spec does. So we can say that humanize. It takes the original data structure, and in place of false values, it returns this error, and we can just call the message out of that. So now we see that X should be an int and Y is a missing required key. So that's kind of nice. And also, because we wanted to do this, it was easy to extend the core so that this comes like trivial. And this is a larger example. I have to make it smaller. Extend like a boss. So this is all the things you can configure. So we have a map. It has an ID int. It's a size, which is enum. We have overwritten the error message, and we have localized it also. So in English, it should be one of da da da, and in Finnish, it's pitäisi olla sm tai l. And age is a function schema, and here we use the static error message. There's error message, which is one of the special keys, error fn, which is another special key, and there you can give a function which takes the whole error and the top level options, and based on that they can generate this string that like value was this and should be greater than 18, and you can localize that also. And then we explain something which is totally wrong, and we humanize that. And in the humanize, we can also like overwrite the default. So there are default like error texts for in English, but here we want to have Finnish. So we can on the fly explicitly say what are the defaults. And what is returned, it says that ID is a missing key. ID, so that was a special thing. It's in here. So the default for missing key is missing key, and it says like, what's the key missing? Size is something like that. Age, it gets the number, which was wrong and should be greater than 80. And now we can localize that to Finnish because that's nice. Puuttuu avain ID. Size pitäisi olla sitä. Age 10 pitäisi olla enemmän kuin 18. So like, and I think this has now all the features which we have been doing in project to project, these like internal models. So, and everything is explicit again. And this starts to look like a bit messy because there's lots of stuff, but it's only data. We can say that like, define this small, medium, or large. It's something like that. And we can say define age, which is something like this, so we get nice reuse, and we say that this is small, medium, or large, and this is actually age, and we get the I didn't repl was dirty, yeah, the same thing. But this does, so they might get hairy if you put all these definitions over there. You can have these encoding definitions and generators and whatnot, but like you can make them reusable because it's just data. Any questions for this?
There is a question in the chat. I'll try to read it.
Yep.
It says, won't allowing multiple registries result in parochiality and or name collisions? Do you see the chat, Tommy? I was aware of what...
I think I have to stop sharing now. Now I see the chat.
Okay.
Sorry, how do I read that? So the last one?
If you scroll up to 735, that's when the question was asked.
7:35, it's 8:35 here.
Yeah, 8:35.
Yeah.
Thanks.
Yeah. So won't allow multiple registry result and or name collisions. Definitely. So you have to have like, but I think that if you have like one registry and you with those you redefine these like top level things like validate and explain and transform, and like create these helpers which only use this one registry. It always uses the same, like it always uses the same names, and like because in spec there's this like anonymous like keys, and I think like everything in Malli uses those. So there's no special definition for namespace keys at the moment. So if you have user/ID. You can register that into the registry, but then it has always the same meaning. If you have another like domain, for example, in Clojurescript, you have defined user/ID is totally different, and you start to like change schemas over wire, they might collide. But I think like with the like serialization protocol, there has to be in anyway like these both the definitions and then the like values. So if you only use these like anonymous or like one-time keys, which where you always in the map define that it has a key ID which is an integer, it has always like local meaning only. And if you want to like define that user/ID means something, you have to like communicate that over wire too, and there should probably be some kind of registry conflict that you are talking about user ID with integer, and I'm thinking it's like it should be string, so they are not compatible. But I think it's good that we can like figure that out before anyone starts validating. So when we are like creating the schema objects, we can compare the registers. If that was answering the question.
So I think the answer the asker got got a good explanation. I see that he said thank you in the chat.
Okay, sure. So I will go back to sharing. Next, generating values. So Malli generator, based on test check and test chuck. They are the dependencies. So looks like, because we are using the key functions like spec does, so it looks really much like that would like in spec. So we can generate random keywords. That's nice. We can use seed that's exposed to the top level API, so we can like fix the value, so we always get the same results. And then we can use size, which is the term in test check that like what is the like value size. And regexp work too. So this is the reason why we use test chuck. So it has this regexp awesome like reverse parsing, so we can generate values from regexps. It doesn't work in Clojurescript at the moment. There's an issue out of that, and I think there was good reasoning why it's not implemented. It would be nice to get that working too. And then you can overwrite things. So in any of the schemas, you can have these gen elements, which is list of the possible values. So we can say that it is string, but it will always generate one of these. And again, it's data, you can put it over the wire. And then there's at the moment this fmap, which is directly from test check. So it has this fmap function, and we can say that whatever gets generated, like map that afterwards with this function, and you can get these like, actually there's seed, let's take the seed away. That's bad because it's always doing the same. But you get something with always starts with Kikka. And I think we discussed about exposing some of the generator functions always also to SCI. So you could use like this gen / each of and this syntax. So this also works, but now it's like a function value. Function value, so like we cannot put it over wire. Now we can put it over wire, and the same works in Clojurescript. Persistent schemas. I think this is the like main reason why we started doing this library. So we wanted something that we can put into the database. We have built like systems for like startups for many years, and these multi-tenant systems where at some point we realized that actually the data models themselves become the first-class things that the users should be doing. And if you build this nice editor, you can define your data structures. How do you persist them? And at the moment, the current libraries didn't have like good solutions for this. So this is what we did. So we take the Malli Eden namespace, we have some kind of schema, and we say write to string. And what happens is we get a string representation of that. And it's basically the same in Eden. If we want to read that back, we say read string. And what we have is exactly the same schema. And now we can do whatever. So we can say that validate. And let's say that x is 1 and y is 2. And it's false. Let's explain that. Explain. It says that x should be greater than y, and if it is, it works. And this is all you have to do. This works in Clojure, in Clojurescript, and in Graal VM. And big thanks to Borg Dude for making SCI and Edameme. And I think with this now it doesn't work. Edameme says that there's like I have no idea how to put that value over wire. Now we can do it. It's a bit slower to parse that. It's interpreting the function, but it's still, the performance is still okay. And if you're running local validation, you define the rules in the server, you can basically eval them if you trust them, so it's as fast as possible, and you can use this like form to put it to the client. And if you have a browser, it doesn't matter if you lose like 100 nanoseconds for validating something locally, because you have saved the round trip to the server to run it over there. Yep. Next separate thing is the provider. So spec provider, F# has these type providers, and for Clojure spec, there's spec provider, which is really awesome. And I was checking how that works, and if there's something that we could like use in Malli, and it's the 66 lines of code. And given that we have some kind of values, for example, here's a vector of two values, and we ask like, can you figure out what would be the schema for that, and what it gives out is this. So it's not perfect. It knows they are both maps. It's a string, set of keywords. It's kind of right. Address is kind of right, but long lat is a vector of double. It should have guessed that it's a tuple of double, but it doesn't do that at the moment. There's an issue out of that. There's like so much we can do better here. And like, I think this is really exciting in the sense that my colleague Kimmo was just using this feature today in the project, and he was taking the large configuration files of the client and ran to the Malli provider and said that it guessed basically everything right. So that's awesome. And like, then we can provide samples out of that, and of course they're valid. So we take the samples, create a schema, and then validate everything, and they're all like right. There's the one issue. Let's see that. There's a list of things that doesn't work at the moment, could be better. So maybe tuple enum or min max map of, and like there's like, oh, I haven't actually answered that, but definitely like spec provider has many of the things like already done. So let's like use that. But in F# you can, this is only from example data, but they could be and should be like from JSON schema, extracting the Malli schemas and protocol buffers, whatnot. And just like, I think that we will sample the JSON schema so that given a JSON schema, you get the Malli, and after that, it should be easy for anyone to write these like providers. Full example. This is from the README, just like how the like working with Malli works. So we have an address. It's like a map of maps. We can explain that. If we get errors, we get this nice structure with we have schema value and the errors and all the paths, which is the actual pointer. You can just say get in, and you will get exactly the schema definition which failed, and then like the value pointer, humanized errors. Should be keyword, missing required key, should be double. And then like real life JSON transformation, if you have something coming over the wire, and in JSON you cannot have a set of keywords, so you will get the set of keywords as a list of strings, but when we use the transformation in JSON context, they will be transformed into this set of keywords automatically. Transformers, there's JSON and like string at the moment. There's also this strip extra keys transformer, and I think there was some collection transformer. You can compose them. This is from spec tools. Just took the same code from here there and cleaned that up. So here we say that JSON, but drop all the extra keys. This is something that is coming over the wire. There's extra keys, evil and dark. Then there's this limitation that you cannot have this set of keywords. And when we use that transformer, it drops the extra keys automatically and then converts the tags. And that's automatic. And this is like, there'll be a lot of discussion like, should this be in the scope of spec? And I think that it should be. It's like so important to be able to like easily drop out the keys and do this transformation. And we have been using that with schema for a long time. So, but now it's in Malli. There's the schema merge, like because it's data, it's quite simple to take multiple schemas and put them together. There's idea of making also this difference and intersection, all the set theory things, and I think that's also nice. But the code for this is actually really simple. We just walk the thing and basically merge stuff. Sample values for that schema. And then like provide schema from the sample values. So this is the best guess. If you would generate something that this is the thing that comes out. 50 minutes.
I just want to quickly interrupt and ask if there are any questions. Because I really feel that I'm learning a lot now, but the tempo is, we have to pay attention. So are there anyone who want to ask something that they haven't got the chance to ask yet?
I guess no.
I guess no. So I guess we continue.
Yep.
Thank you.
Yeah, just a few extra features. So the walking over schemas, this is important. So you can write this visitor and say that take the address and walk it over and collect stuff. And this is the easy way of making this schema to something else transformation. And for example, the JSON schema transformation, you can say that I have an address, I want JSON schema out of that, and that's the JSON schema basically. And because the walking is built into the schema, so it's the code for this is quite simple. And the Swagger thing, this was the 21 lines of code. It's based on the JSON schema, but with few exceptions. So Swagger schema has these limitations, so it cannot have these tuples, so it has to have these X items, which is says the real type. Performance. One of the things, I was building spec tools and I tried to make as fast as possible, but it was really hard. And for Malli, just took the performance as first principle that it has to be really fast. There's this validation, explanation, and transformation. They are in the hot path, so they have to be as fast as possible. Let's take a test. Let's have criterion. This is something that our API consumes from the internet, JSON pizza. So we have the toppings, which is in the format that JSON can understand. Then we have the schema for that, order. Then we make this, now we don't use the transform function because it creates the transformer and doesn't reuse that. We create this transformer for this order in the JSON context. And what we get back is some kind of function, which takes the JSON data and returns it in the order scheme. And when we run it, we see that the toppings have been converted into right format. Let's see how fast that is at the moment. I'm not comparing to anything, but the transformer recursively checks everything, and if there's nothing to do, it returns nil from those branches. It's recursive, so if there's nothing to do, the whole thing returns basically nil. In here, it should see that this needs to be transformed. It has to do these few operations of adding this, associating these toppings and converting the values. It takes some time to run the quick benchmark, but it shouldn't be that long. Okay, it was 650 nanoseconds. Let's make this small change that our business decides that we don't need the toppings. And what happens now is that the JSON pizza and the order, by pure luck, actually this order describes something that can be represented in JSON. So we have created this JSON to order again. We can see that it works, but it doesn't do anything actually. Well, it doesn't do much because it's in the same format as it was. So let's run the benchmark for that. That was with one change that was, or one transformation, it was 660 nanoseconds. With this small change is 3 nanoseconds. How can it be? Let's see JSON to order. It's identity. So actually the transformations, the recursion realized that there's nothing to do, and in the top level nil was returned, and the top level transformer function doesn't want to return nil, it returns identity. But that's basically there's nothing to do, so you cannot just beat that. And that's automatic, so whatever you do, you just define the schemas, you define the transformation context, and then you just say that just work, and you get out of these nice fast functions. But there's still much room for improvement. There's the Boolean simplifier that Mika, my colleague, started to do. It's a nice thing that if you have this and int, pos int. So this is kind of nice, but actually the current validation runs all these three, and actually this could be reduced into pos int, positive int only. So that's the and because we are using these separate states for compiling things, so transformer does all the work for you ahead of time. So we can run these. There's just we will add just hook that, can you simplify this? And it basically by default returns identity. And if you provide this external simplifier, you can do whatever. And another thing is the data flow optimization. So, for example, if you have int and then you have something like, it's almost the same, but you say that it's greater than 1. So these should be merged, that is also should be positive int. And when you generate values, at the moment, the generation takes this as a generator term, so it generates any kind of number and checks that they are over 16. But if we could this like term merge into this in generation, we could say that generate numbers which are always greater than 16. The generation would be much faster. But plan is to just make these like hooks that if you know what you are doing, you can provide like good implementation for optimization. But that like transformation optimization was the thing I wanted to show. Last things, programming with schemas. And I will show the like prismatic schema version because we haven't done this yet, but this is really important. And in prismatic schema or plummetic schema, it has been there for like 4 years at least. So let's take the schema core. Schema tools core is a library from us, and have this like address schema. And in schema, you define, in prismatic schema, you define these optional and required. You have these like special markers for the keys. But and because of that, they are not normal data. If you say that from this map get this city thing, you have to say that get this optional key city thing. So you cannot like walk it easily. But in the schema tools, there are these helpers, for example, select keys, which knows how to handle these optional and required keys. And you will get out this like correct answer. And you can say that remove this ID and country, and the country is required key. It's a wrapped, but it knows how to handle those. And this is what I would like to see in Malli too. So you take any kind of schema. You can say that like in prismatic schema, everything's closed by default. In Malli, we are not sure. It might be open by default. It is the common, like there's a voting in one of the issues. So what is a good thing? And I think that whatever we do, we would like to hear what people think. But in prismatic schema, they're closed. But we can say that open everything, then make the top level optional, then update something under the country and make them optional. And what you get out is this like map which says that all the top level keys are optional. There's this openness definition in the top level, and the country is optional, and under that there's name, and it's also open. So with few like this core like function kind of helpers, we could make this totally different kind of version of the address schema. And this is something that like definitely we will be adding. There's this one pull request which started to do this, but there's a lot of more work to do. But we want to do this. Visualization schema, not yet there. If someone is really interested, happy to see that. We did this for prismatic schema some years ago. So given this kind of like schema definitions, you will get some kind of like UML-ish diagram out. And this was big thing when we had the enterprise customer and they wanted to see that like, what are you doing? And just like create this tool. This is maybe 100 lines of code, but just this tool which prints out the graph with thing, and everybody was happy. So definitely want to have something like that in Malli. The set operations, as I said, union, intersection, difference. And this is a really good feature. We have used similar feature in one of the projects. And it's really nice because if you define, for example, a human verb, that it has to have this like 10 fields and these nested data structures, and you can generate a form out of that definition. And then if you have like partially filled data coming from some other source, you can just like take this like difference or intersection of the form and see what do you have to still like give to me, and you can generate form out of that. And it has like many nice use cases, and I think it should be really simple. You have just like, you have to figure out how to handle the optional keys. So if you have like optional key in one schema and a required key in another one, you take intersection. So is it optional or not? I have to just like think a bit more, but after that, I think it's a nice feature. Next step. So we hope that Malli will be out this year. There's like all the things we want to do are in issues at the moment. So there's 30 issues, most written by us. So more robust errors and like JSON schema to Malli. Not everything is required for 1.0, but we want to like, this is like breadth first. We want to see everything that will come up, and the design will be emerged from that after we have done all the things that are needed. So the core might need some few extension points, and after we know that the namespaces are good, then we will publish it out. I think last thing I would like to say is like bit of the differences people have been asking. First of all, why? But like, what is the difference between Malli and, for example, Spec? And here I collected some of the things that like Malli does, but Spec is not doing, and vice versa. And then are they coming? And I think most of them will be coming. So the original reason that we couldn't persist the specs, it will be coming. So that's Spec 2 in its scope, and looking forward to that. There's this Clojureverse discussion about like what needs to be happening when you are starting to persist or share schemas over the wire. And the question which was asked, like, what about the registry collision? So there's like one answer to that. Schema metadata, Spec doesn't have that at the moment, but there's the open issue for that. These like error function as data, I don't think that Spec will have those. Spec value transformations, this makes me a bit sad, because I would like to throw most of the code from Spec tools away, and if just like Spec core would have these ways of doing those. But at the moment, if you do transformation, use Spec and Spec tools, and when Spec 2 comes out, if it doesn't have value transformation, we will port the Spec tools to support Spec 2. Spec walking, there's an issue for that. And then this JSON schema transformation, you can use Spec tools, Swagger 2 Spec tools, inference Spec schema values. In Spec, there's Spec provider, which is awesome. And for human errors, there's phrase. So you can do most of the things with Spec. And I think like Spec is much better in many ways for like development type things, because it has the regexp specs and the function specs, and it's in the core. So I'm not expecting that these will be like anyhow competing. So if you need fully dynamic systems and like API things, you might want to use Malli. If you want to have like something development tooling and like stuff like that, you will probably use Spec. It's better for that. Things that are in Spec that are not in Malli, and should they be there? This is asked. So in Spec, you can have these key sets. In Malli, you don't have that, so you have to define the keys all over again. But it could be made so that map, instead of having only these like key value pairs, they could have these registry entries. Might be a good idea, I'm not sure, or a different element altogether, like key set, which would have this. Regexp specs, like I think this is like the brilliant thing in Clojure Spec at the moment. This is Spec 2 syntax, and the syntax in Malli would look like this. So not likely to be adding that, but if that is something that someone would like to do, I think it could be done. And pull request welcome if that is needed by somebody. Multispecs, if we have time, we could implement the multispecs, because I was doing that. It doesn't take much time to make simple version of multispecs, which are like closed, but there's an issue for that. And that's definitely that something is needed. It's like a really great feature of Clojure Spec, and Malli at the moment doesn't support that. Conform, unform, they are not, Malli doesn't have those. And someone asked that he might need those. If someone needs them, just like write an issue, and I think it could be done. There are no named branches in Malli at the moment, but there's the explicit indexing because it's vectors. Function specs, this is something that will come. I will make this. I'm looking forward to this. Schema had these sdefn definitions which allow the return value, and I think there was one library for Clojure Spec which is using exactly the same format. So you can have this special defn where you can tag that the return type would be tuple int, and for the arguments you can say that these are the expected types. This doesn't work Actually, this works because it's not validating, but like the syntax would be like this. And I talked with the Prismatic guys some years ago that like how should we do this, and they say that definitely just take the code and like make a new library or just copy the code into your own library. So there's one spec version with this kind of syntax. So I will probably like find who was doing that. Was it in Orchestra or where, and see that if we could share something. But cursive, I understand this. So if you have something which is not used, it's like showing that. Some syntax definitions, but I think that's about my presentation. What is Malli? I will put all the material, this REPL session into the gist. But why is Malli? We thought that there's something missing, that a fully dynamic schema system where everything is data. What is Malli? Experimental library. There's a Malli playground. I will show that. Just cooked that last week. So demonstrating the stuff. So this is running Clojurescript. There's no server for that. It starts with an empty like schema and value. And if you put something there, a schema and a value, it on the fly validates those. There's a few examples, for example, X and Y map, this kind of schema. And like with this value, it says this kind of errors. There's an example for user and address. And like if you start fixing these, for example, this would be probably 3. So it's like quite fast. And there's a small debounce for like creating the sample values, creating the JSON schema, Swagger schema, invert schema, and sample values from the invert schema. There will be others. The visualization thing will be here at some point. But like this way you can say that tuple, string, and int. And then you can say that kikka 6, and that's valid. And now if you want to share this with the debounce, it puts the query parameters. So I can take a new browser and just copy paste the thing, and it's over there. So you can, this really simple tool, but to like, there's also already like few bug reports from this tool. So it has given already big value. But like recap, schemas and properties as data, validation and explain the basic functions, a schema serialization, deserialization without eval, two-way value transformations, generating values, inferring values from third-party sources. Now it's only examples, later JSON schema, etc. There will be tools for programming schemas. There is no global state. There's explicit everything. And error messages are first class because both for developers and users, and highly configurable. Everything that has an opinion, it's probably configurable. So you can have your own opinion. And idea that it's probably like a library for making schema libraries instead of a schema library. And there's lots of open opinions, and they are in the issues. If you have an opinion of those, like go and write your comment. So we haven't locked basically anything. We're targeting JVM, Node browser, and GraalVM thanks to like Workdudes, SCI, and Edameme. It works on all platforms, and looking forward to like community feedback. And yes, it is really fast too. And the links I showed earlier. So like there's some new ideas, but mostly like best ideas from other libraries we have collected into one package. That was my all. So thank you for listening, and happy to answer any questions.
So thank you, Tommi, so much. I really enjoyed the presentation, and I felt like I was continually learning. So this was exciting. So are there questions? I don't want to occupy all of the screen time now. So please take the microphone if you want to speak. Then I think I'm going to start off with my own question.
Yep.
I was really curious about the playground, and I was wondering if you can talk some more about your experience using that in projects, because I kind of envision not having to explain people like the data looks like this. But have you tried using it? how do you use it? And if so, what are the experiences?
The playground, I haven't used this, like this came out like last week, so I haven't had any like real use for this, and I'm not using Malli personally in the projects, and I think none of the Metacin guys are. So Kimmo was like poking that could it be used, but I think that this is basically, if you have checked the GLJ Condo web, so I've been chatting a lot with Work Dude, and there's somewhere over where's the web? But like the playground idea is originally from here, hosted here. So if you look at the graphics, it looks pretty much the same, the buttons, the bootstrap, everything. And I think these are really great tools, for example, like running the linting or refined it, or there are multiple tools. I think SCI has at the moment a playground. And I think like this is great because in Clojure you can do this. You can, SCI, do we have that? No, back to safety. So I would think that, and this was basically the tools we have been doing in the project, they look a bit like this. So if we have given like a schema editor for business users to do, it's either like graphical or then you can expose the like hidden thing. And this is just was like a test for how to make it in today's library. So there's Code Mirror and like Eden and the Malli libraries, and just like put them together and small debound. So, and it's really easy to do. So if you need some kind of, and because you can run basically, if you look at here, so we can have the like things that looks like source code. Actually, it is source code. So you don't even have to quote these. So basically you can add these business rules here, and or you could build a rule system where the like rules are Clojure code and there's different schemas, and just put them together with these small libraries.
So I just want to say that WorkDude actually posted the link in the chat, which is convenient when the library authors are watching.
Did I put it? Stop sharing. That's one, and the other one was. I don't have the other one. But whatever, like, let's fix that one. Why is that? Should be another link. Like, oh, it might have broken that. Yeah, the chat seems to be killing the last link is broken. But like my repl session should be in the chat at the moment. Thanks, Karin.
Are there any other questions?
Yeah, so maybe if I can ask, I'm Daniel. I wanted to ask if you have thought about the opportunities with tooling that could use plain data schemas. So, for example, you could imagine that the linter could know about the type of data that it expects, and then it would shout if it doesn't conform. Or you could imagine that the autocomplete of your IDE or editor would complete data examples that conform to a schema. And I think in the F# world, they have nice examples of doing that with their type of providers. So I was wondering if you were imagining these kind of opportunities of how people could use Malli for tooling.
Yeah, I would definitely hope that, because I think it's so simple that because the tuple is just a vector with few things, so the syntax is really easy to like write, And it's really easy to parse because it's just data. So the library to do that, the Malli is, the core is so small that it could be embedded in many places. And I was just taking the, as you mentioned, the F# provider things, and it has this Visual Studio integration where, for example, if you point it out to the external JSON schema, you get this auto completion. So what kind of users dot address dot city dot something, you can like browse the whole model. And I think it would be like really like awesome. And I think what I have been like wanting is the closed multi-spec thing. And I was just yesterday thinking about that. So would it help the tooling? Because if you know, for example, that you have this multi like schema which has 3 possible options. So this, for example, you can have map, which is like order, or then you can have this like customer created event, or 3 different options. And now if you want to pattern match those, you could probably like generate the code to match that from the definitions, or even sync them. So if you are trying to like read that you have this one pipeline which gets data which is one of these 3 like schemas. So could we check that, like, are you checking against the right data structures? Because now in Clojure, you just might have a function that handle event, and then you read the type out of that, and based on that start destructuring the keys. And when the like schema change, your destructuring code might be totally wrong. You are like reading the wrong keys. And I think that these simple data definitions could help there. So if we know that this is the like thing that is coming in, because in statically typed languages, you usually have some union type, and you just say to the IDE that like something is coming in that generate me the code, and you have this pattern matching with these, all the options, and they keep in sync. And like in Clojure, I think we could have like 80% of that if we just like, I don't know how to write the tooling. I hope that like someone picks up this like idea of having these simple portable data definitions and writes the tool. I'm looking forward to that. But my question would be the same, that like, here's Malli, can you do something like that with this? And if you need something, we are happy to add, because it's just like the beginning of the whole story. But I think that one thing I'm going to use that is, and one of the reasons we started to do was in Rated, there's so much configuration, and at the moment we are using spec 1 to validate, for example, configuration. And in spec 1, there's no way to merge deeply nested specs together. So what I wanted to do is having this closed spec validation for the whole thing. It starts like that you have like this top level configuration, which might be like integrant configuration. You define the databases and servers, and the servers have options for ports and virtual host, and they have sub options. And somewhere you have the routing table, which has all these in Rated, there's multiple components which contribute to the specs, and you have to merge them. And then you want to see that is this valid? And just, I cannot do it with spec 1. I probably could do it with spec 2, but I didn't want to wait. So started to doing Malli, so that now I know that like I want to deep merge 2 things which are madly deep, and they just work. And if they don't work, I can blame myself. So, but then having this like error messages, I didn't show the developer-facing error messages, but I talked to Ben about Expound, so would he be interested in contributing to Malli? And he was busy, but we were chatting a lot about how to do that. So there's actually a branch of having these Expound grade error messages for Malli. And that's really nice if you have this, like the whole system is defined with Malli schemas. And for newbie experience, you spin up this like big web server, and you just put some Eden file, some port which is like in the wrong place. You will get this like fig wheel dust, so that this level has this extra key, and it should be in this level. And if you run it in the background, you get this instant feedback. Now it's like in Rated, there's this nice error messages, but if you use top level integrant, it has different mechanism for that. If you use immutant, it doesn't have any kind of validation for the parameters. If you use Hikari database, it doesn't have, just having this one place to put all the configurations and run the validations for the whole stack. that's something like want to test, and it also might affect how like Malli should be modeled. So.
Are there any other questions?
Yeah, so I would have a question. So how would I, or how could I use it with write-it? So basically right now I'm using it just with Clojure spec, and how could I integrate it for the coercion in there?
Yeah, so for that there has to be this rated coercion module for Mallit, and I think like that is something that should be happening next, because that's a good test to see that everything is like working. So I think the feature-wise everything is there already. So it's just like we haven't done that. And for example, the spec coercion module is maybe 100 lines of code, and schema coercion maybe 50 lines. So it would be really simple. So that I cannot promise it to you until before tomorrow, but it should be really trivial. And one thing that needs to happen, we have to like push out a version of Malli, because rated uses like Clojure, so we have to have some work in there that it would ever work. It doesn't use depths.
Perfect.
But that's also like in spec at the moment. There's like two syntaxes. One is the data spec. We did this simplified thing, and it's too simple, because then people ask that I have these like map-like definitions. I could share the screen just for a second. Rated. So let's go to the examples. There's the like ring spec Swagger, and then there's this. Here is other in data specs. No, sorry. It needs to be this ring Swagger. Pedestal Swagger. Yeah, here. So like here are the parameter definitions. This is the data spec. It's a layer on top of Clojure spec, and it tried to simplify things. But as soon as you need something extra, so we reused all the like forms for maps and sets and vectors, and thought that if you just need those, everything is simple. As soon as you need something like X is an OR of integer and something else, you have to like you fall into between these two realms. And so like Clojure spec 1 is quite like if you can use that also, but you have to predefine the things. If you want to like inline things, data spec is good, but I think Malli does both quite nicely, because you can have these this query would be a map of X and Y, and you can into the top level put these titles and things that like contribute to the Swagger specs, which is a common question. So how do I like add a title to this total? You cannot just do it, but if we take this code and make a modified version of that, no, it would look probably like, where is it? Like say that it's a, what was the total int? Map which would have total int. And now the question, how do I add like JSON schema title here? I can say title is my body. If you want an example, you can say that like JSON schema example, and you can say that total is, for example, 1. So you can do stuff like this, and like there's enough syntax for making any kind of complex scenario work, but it's still only data, so you don't have to predefine everything. You can inline everything you want. I lost my battery over there. Let's put my output to. Could you please tell something? Say something?
Hello.
Hello.
I can't hear anything. Oh no.
While Tommy is fixing his speakers, I guess this is another good time to ask if you have more questions.
Hello.
Hello.
Yeah, so I ran out of battery from my headset, sorry. Yeah, but I was saying that this is the way it would work with Rated, and it's just like maybe a few hours of integration work and few tests, and then it should work.
Perfect, thank you. I will try it, definitely.
Yeah, so maybe if I could ask something more. So in the last few weeks at my workplace at Localize, we are experimenting with kind of a domain-specific language for doing some data processing. And we wish to allow a large group of people who are not developers, who may not be knowing Clojure, to be able to write this kind of domain-specific language, which is some kind of hidden structure. And we feel that it is a general question, and that it may be an important question, because we wish to see how people who do not know Clojure can learn Clojure gradually by looking at some limited example of hidden or of Clojure code. And what we are trying to do is indeed to define it as a limited case. Not all kinds of data structures are allowed, but something limited can be constructed. And then it is, again, a tooling question. Or maybe a UI question. How can we create the perfect user interface to allow someone to create hidden data structures that conform to some schema? And can we automate this relation between a schema and a UI? So these are our naive thoughts, and we are having naive experiments, but I wonder if you have similar challenges sometimes.
Definitely. So in one of the projects, there was, after the project, there was, at some point, we needed to have this simple rule management system. It was like templating, basically, rules for how to print out templates work. And my first idea was that I will create this Eden editor, and people will write Eden, and it was using the code mirror and schema validation. There was all these nice floating error messages, and I thought, okay, this is something I can cook in one day, and thought that it will never go through. It has to have these lots of forms, because they were business users and government people, so that they are not hardcore computer science users. And I presented the tool to them, and they said that, this seems to be good, so I think we can do that. I was like, wow, this is really nice. So after the project, they started to use that, and they had to make this organizational change, because the title for the person using that application had to have some kind of I don't recall what was the term, but they didn't have this kind of position in their company. They were filling out forms and doing these domain specific things, and suddenly they were almost programmers. So they had to have this new title, and one of the persons, this older person, took the title and said that he will start doing that. And he was really proud of that. And I'm not sure if they still use that, but it was an eye-opener that it's really simple. And if you have good tools, for example, Code Mirror, and that my Malli playground has the par infer, so it automatically puts the brackets. And at the moment, it doesn't show the errors, but Edamame shows exactly which lines and which marker is bad. And if you just add that also there, so you have this limited sandbox of things you can do. And there's no auto-completion at the moment, but it could have. And I think the toolings get better. We don't have to do anything, just some of the JavaScript code mirror things have auto-completion. I think there's a hook for that also. And this is like big things, because in Clojure we can think like dynamically, so everything is dynamic. You don't have to like fix up things. In my last Java project, there was one last thing we had to change, and it was like going through all the layers. It was like in the database, we changed the table, and the Hibernate mappings were changed, and the data transfer objects were changed, and everything was changed, and the REST client was changed, and the server was changed, and it was huge amount of change. I was wondering, like, no, this can't be this hard. So huge change for small things. And now in Clojure, because things are more dynamic, so you can put any, you can have non-SQL databases and have these loose schema checks in the database, and you can just like easily store things, and you can push like the boundaries forward. So push the power to the users to do stuff. And in the Java times, as I mentioned, the one way to make these rules dynamic, we had this like Groovy sandbox, and the business people were writing Groovy into this small text box, and it worked, and it was kind of awesome. But in Clojure, now that you can just like write Clojure functions which are safe through the SCI and edamame into this Eden thing, and they just worked. So that's like brilliant. I don't know what we can do with this, but I definitely think there's a huge opportunity for writing apps for business people, and the live preview and everything. So it's just like built into the language, basically. And one thing like in the project I'm currently doing is where we use the prismatic schema, was that we have these state machines which were running the whole system, and the processes, the state machines were like described as Eden in the backend. And the only thing that was not serializable was the like schema definitions. And the project is about to end. We had these Clojurescript Clojure common files which had the schemas, but it was like bad because we had to know them in advance. I would have liked that like there's just this definition, we can put it to the database, and there's just like pick it from the database, and this is the process, and it like runs like this, and these are the views which are generated, these are the actions which are allowed in which step. And with Malli, it would have been like available 1 year ago. We would use that and just like extra layer of dynamism, so that build this like web editor for the processes. And just like after 1 month, we would have been done, because just say that we built this engine and you can do anything yourself. And I think in Clojure D, there was nice talk about this state machines, workflow engines in Clojure. It's a match. I remember that from the title. But it was also really good that like adding like live stuff into the like Java-based BPM engine, workflow engine via the web like interface. So there was ability to add some like attributes to the processes, and they were adding like Clojure code and running the repl there, so they would like parameterize the processes through the web UI. And this is something that I think that there will be more of these things coming in the following months and years, because we can do that. The JavaScript people can do that with JSON schema, but it's like really big anyway, and like and hopefully the like Juxt guys, they have the Jinx library for doing that, so it will make JSON schema like more Clojure-ish. You can use that from Clojure, but like Malli is another like way of like taking the Clojure first. So hiccup under Eden. But please find use cases for that, and if you need something, we are happy to add it to the library.
I was really curious, a follow question, because when we were, as I'm hearing you, everything becomes data-driven. So we take all the parts of the application that we can, and we make them data-driven. But what does that look like in the end? Do we then exchange our code editor for running something against a database, or what do you envision that we're doing? Or is it more for business people, more powerful tools for business people so that we don't have to do anything? If you would like to comment on that.
Definitely. I would say the latter one, so that what I'm seeing at the moment is they're tools for the business people, and someone has to build the engines, but like the business people at the moment, like seen so many projects where business people want something, and what they will do, they will create a backlog item, and the software guys will do something, and in end it will might end up having some kind of UI which you can see, or then it's just behind the cover something happened, and like in many cases you can expose the things for business people and in Clojure, because you can validate things and you can like preview things that they don't have to like be afraid of things that they will break stuff. And for example, one of the features in SCI and what Malli is using, this termination safe. So because you can write any kind of Clojure core code into these function things, and there's an interpreter, it has these limits that, for example, if you have the infinite sequence and you say that take the last one of those, it will have this default, like it goes only 100 hops and then says that too much. So you can create these limits. Another we made, was added to SCI was this termination safe like mode. So when you enable that, the things that might like cause the like non-termination, they are not allowed. You cannot use recur and few others. And that's kind of nice, because after that you know that you can run simple things, ifs, else, macros, looping, whatever, but like it's safe. You can run it wherever, and if it's come from the browser, you can still run it on the server. Hopefully. I'm currently testing and trying to make it break, but like it seems to be that it's good.
So you would kind of be comfortable to use that without having someone be really clever and have your machine spin at 100% all the time?
I would definitely recheck the like integration to SCI, because at the moment Malli is depending on some SHA. It's not like depending at the moment on the stable version, because Malli is not stable. I just moved some namespace a few days ago into some other place. So if there are pre-alpha users, sorry for that. But try to like freeze most of the things as soon as possible, and check the libraries that they are all like good before having this public release. It would be really bad if there would be some eval somewhere over there and you can just like hack anyone's computer using Malli. We don't want to do that. And like now there's the termination safe thing and testing that. But I think like I wouldn't want to program in like web editor, definitely not. But I would like to build tools that enable people who were using just having this Jira ticket, like pipelines, ordering stuff from the developers, having the power to them, and process engines, rule engines, like dynamic schemas and running graphs and stuff like that.
So I think I actually have a somewhat related follow-up question. Is that something you want to ask from the Clojure ecosystem? If you could ask the people working on Clojure as a whole to focus down on one problem, would that be part of it, or would you kind of point in a different direction?
Sorry, could you repeat the question? I was just thinking something. Yep. Sorry.
So I thought about this question earlier when you were talking, and basically, what do you want to ask from the Clojure ecosystem? If you could direct a bunch of us to work on something, what would you consider to be important? And since we're talking about these rule-based systems that at least I think would be powerful but require a lot of effort, is that a direction you would want to go in?
Definitely like a direction, but I think like Clojure community at the moment has like so many like brilliant minds, and it's like overwhelming to see like the quality of libraries that are popping up, and just like enjoying the ride and seeing all these linters and like whatever GLJS npm tools, shadow GLJS and stuff, like it's like really nice to see that what is coming out. Like about the rule engines, we have done like what has been needed in the projects, and I know that if there would be infinite amount of time, I would probably like doing like all the tooling, because we have seen what is needed, and like it would be nice to do, but like we don't have like unlimited like time to write all these stuff. So it's all usually, for example, this Malli, like there's just like enough ideas were in the table, and we decided let's do something for that and try to push it out. But now there's 160 libraries I think we are maintaining, so have to do something with that. But just like for the community, so keep doing the good stuff. And one thing that would be nice is I think the like developer experience, and there was just the like questions about like what can we do for that, what is expected for Clojure 1.11, is it the next one? And like my biggest wish was that like the compile times would be like smaller in the client side. There's this initiative of like having this client side compiler AOT cache thing, which will solve this, but it's something that we cannot do. It's the like core team which is thinking about this, and it's a hard problem. But like what we can do, we have this library called Virhe, Metosin library for having these Elm ETA like great, like good looking error messages, but they have no content basically. So Rated emits those, and I have this branch where all the Malli errors are printed with that, so they look really nice. But the core errors, there's enough data to build beautiful errors from the core messages, but we should have this common formatter. And happy to push this, our Virhe library, to GLJ common if that is a good start. If it's a bad start, looking forward to someone to making a better. So it's something that would be nice to have this like coherent experience. So tools that like start quickly, and you get this configuration which is like unified in somehow an error message which is somehow like on the same grade. And but I don't know, it's something that things that should happen, and I don't know how to make them. So hopefully someone applied for error messages for GLJ together, and I'm happy to like point out to this what we have been doing. So this is initial things, and we don't have probably time to finish them all, but it will be like between Rated and Malli, they will have like nice error messages.
I also just want to say that I think it's great what Medicine is doing for the Clojure community here. At least,
thanks.
That's my impression.
Thank you very much.
So.
So I guess Theodore has some connection problem for a moment, and maybe he was going to ask us if we have any questions, and maybe he will be with us in a moment. So can I ask, what was difficult? Did you have any kinds of data where you saw that Malli cannot express your assumptions about the data, or that you cannot do the inference of the schema from the data because it was too complicated or difficult in any other way?
I think like what is the best part of Clojure spec is the regex specs for like sequence like specs basically. There's no such thing in Malli at the moment. This Plummetic schema had this really simple like sequence specs, and like they're good for most of the things. But when you want to like describe, for example, function parameters with var args and stuff like that, Clojure spec is really awesome for that. And like if I would have data like that and I would be using Malli, I would definitely like see how it's implemented in Clojurescript. And if there's something like we could take from there if we just want to use Malli, or then decide that okay, this is a better, like this problem is this like spec. I can't remember like where spec originally took that. Was it from Racket? But there's probably like few sources which describe how to do these regexpecs. Specs. And like Christoph Grant had this Express library which was doing something like that. So, and anyway, like building Malli was like really interesting in the sense that like you have to poke all the corners. You have to take the providers and the generators and how they fit together, and like the validation and explain, and the human errors, and talk to tens of people how they think about the world, and like just trying to get something like good out of that. But for the provider question, at the moment, like the list of things that the provider inferer cannot do is like long, and I think it's math, and you are the math guys. So for example, if we get this like vector of values which are all integers, at what point do we decide that that's a tuple? Is it like if you have one sample and it has like a list of one number, is it a tuple of one? It might be, it might not be. If you have two samples and both are of 2 length, is it now a tuple? So probably there's like lots of options, configuration, like these limits that need to be set. So if you want to infer, you have like petabyte of data and you want to infer the values, and like you have to have these like some kind of limits that tuple, you need to have this much certainty for it to be tuple, because if you mark something as tuple and based on the first 100 values, it's tuple of 2, and the 101st value would have 3 values, then it doesn't validate against the schema. So you have made it too strict. So I don't know how to do, but like there are smarter people who probably know how this works. But one thing I was wondering for the provider is that I don't know whether people have done that before, but there should be like 2 things. One is the samples, and one is the like correction data. So for example, if we want to have this, like we have 100 samples and it seems to be of tuple 2, but the inferer doesn't know that, and we want to fix that. There should be this like small schema definitions where we say that under user, under address, under location, we mark it as tuple. And then when we infer, we have this like partial schema which fixes some values and the inferring data, and they're combined. So you would get always the same results. And like the best version of this like partial schema would be the full schema. So we know exactly ahead of time that this is the exactly schema which we are looking for, but you could have these partial things. So we would say that we know that all things that are under address look like they're tuple, because we just know that business guy just whispered at us that it was the old system. We had these tuples, strange tuples. But it's like, it should be easy to add, but just like have to dig in very deep and see and read some papers and books and see how it goes. And because, for example, spec provider already has done many of these, so probably just like join forces and see like, can we do like one tool for both, or how does it go? But I think it's like statistics, like numbers, certainties.
I think probabilistic data schemas is something you wouldn't hear outside of the Clojure community.
What was the term?
Probabilistic data schemas. We know for with a 90% certainty that the schemas would look like this, but we're not quite sure.
Awesome.
I guess Rich Chicky wouldn't agree.
And I think like that's also like a nice food for thought. Like how do the like a union schema union is like quite simple, but the intersection and difference, how do they really work? So is it just like you just look at those and see the math how it should go, and it's like trivial, or are there like, do you need to parameterize so that how does it go? So if you have 2 different types, is it like or and or how does it go? So I just like haven't thought of that, but probably there's something to think about. But I think that would be like nice to be able to do.
And now you're still talking about inferring schemas from values.
Yes and not so. I think like if you have two schemas like user and address, you could merge them into user address probably, just like putting them together. Or if you have like a user and a neighbor, and they are look a bit like almost the same, but they're overlapping a bit. So how would you combine them? Or if you say that like we need to collect neighbor information, but we already know everything about the user, so we don't have to ask that, and we can just like cut out the like intersection from that. So we see that like remaining neighbor looks like this. So we just take two schemas and like, what's the difference? I'm not sure how useful they are, but I have this thought that it might be really useful, because at least in one of the projects we were doing this. So it was basically process which was guided to like fill out these like data sets. Some of the data was coming from like automatic sources, some were like set by human. And if you have this like big data like definition, and it goes through the whole like process, and you get data from different sources, you can always ask, so what is left? And you can just like cut out the big schema with the part you know. So you can take values and schemas and take like intersection of those, and then just you know that this is the remaining schema, and if you get data which conforms to this schema, you are okay. And when you can have a tool which takes schema and creates, for example, simple UI out of that with UI component, you can just say that, okay, manual guy, we couldn't get all the data, you need to fill out these 17 forms. And it's just like dynamic, so fill out the things, so we need these before this can ship. So it has like known use cases, but not just for today, but adding the features to the libraries, and then when you need that and re-need that and see that, okay, I knew that this will re-emerge this problem, and we have a solution for that. And that's interesting. Like I think like Malli is the best like quality library we have done. So it's like really tight and small, and like now we didn't have to lock anything. We have discussed a lot, so how it should go, and iterations are like 1 hour iterations, like a few times a week, these small thinking sessions and implementation sessions. It just like evolves and grows, and there hasn't been like many bad choices yet. So it's fun.
Now that you talk about code quality, I just want to note that I took a note previously that I think I learned a little bit about namespaces and just how to organize things and how to make it clear. So from what you showed today, that was educational, at least for me. But back to what you said, because like you subtract one schema from another, or you take data and you remove this part of the data, and now we've kind of understood this part, and then you can say what you have left. Was that in a sense what you meant?
Yeah. So if you go through an example, so if you have like a user and it has like first name and last name and like address, if we have like we have to get this amount of information for all customers, and we like start with, we know that this is a requirement schema basically, and we get the address from some address system, and we know that, okay, what's the difference? What is at the moment? We have value, which is the address, and we have the schema, which has the like common parts and the address, and we check what is the like difference of that, and we get that like the remaining schema is just the top level thing. If we get like the first name from some public system, then we know that the remaining schema is like a reduction of these all the things. And every time we have this smaller schema, and at some point we can just say, okay, we need this information still, and we can ask that from the user.
And just build some generic user interface that can kind of ask about these things once you've established, like, these are the meanings, this is what we're looking for, these are the descriptions.
Yeah, there's, I think there's like all the generated UIs are usually really bad. But if you have like something like workforce, so you're doing like manual labor, some kind of installation thing, and the last thing is that you have to fill out these 4 things. You don't have to have this like, it's not meant for 1 million end users which are like loving your product. It's just some mobile view that the installer guy has to like fill these 3 parameters. And to generate that UI, we can take a schema. And at the moment, Malli doesn't have this from schema to web UI kind of namespace or library, but definitely it will have at some point. There's for JSON schema, there's at least few of those, and in many other. For prismatic schema, there's one library which takes the schema and emits user interface or this form out of that, and it's just data, so it should be like trivial to do from Malli. Just like see how other people have been doing that and are there any good practices, and after that, like having the processes as data and the schemas as data, you can like make these like dummy workflows and like mock the processes really fast. Maybe.
There is this other project that I don't really remember the name of, but it's related to Datomic, and I think it tries to do something similar to this. Does that ring a bell for you? Or so
yeah, maybe. If you say the name. If you say the name.
I don't remember the name right now, and that's stupid. But they have this web UI where they work with the Datomic model, and they interact with this model both at the UI layer and at the backend. And the way they solve the system is that they say that they're able to build things in 2 days when other people build it in 2 months. Just that's where my thought or what you were saying left me.
I probably know the library you are referring to. I haven't used that, but I guess no one else remembers the name of the.
No. But I think that direction is really interesting because it lets us think about the systems in a different way. What if collecting data from users was simple? If you have specifications, and I don't want to write a CRUD application now. I want to focus on other things. So let me write my data schema and let me just work with the auto-generated stuff meanwhile, and then it might be really simple to change it until we know where we're going.
And for example, in Finland, Finland is a promised land of forms. So like all the like electronic, all the like paper processes are put into the internet at the moment. That it's basically like you have this, before you were filling this huge amount of papers. It's like we had paper a lot, and now they're put into the internet, huge amount of forms, and like so many projects are doing those. And we have done our share of those too. And remember, like one of those like form libraries and data definition libraries we did. It's in GitHub. I don't know. It's in Finland. Many of the like publicly funded projects end up into GitHub because they are paid with public money. So few of those are there. But the good thing was that it was like a building permit model, and the like rules were really complex. So there were these like rules that, for example, if you have filled that information over there and some other information somewhere, it effectively puts a warning into third field somewhere. So it was like guiding how to fill them. And actually in the paper, it was like one paper form which had questions and then 2 or 3 forms full of like text. So how you should fill that? And just like putting that in the form that a machine can understand and guide you that, okay, you just said this information and that they are like, because of these 2 information, this is the next thing you have to do. So you have the same things, but like it's much easier to do. But so many forms in here. So, and I think I could pick like 3 or 4 form schema libraries, which are done in Clojure and in Scala in GitHub. I don't want to find them now, but like they exist.
I've been asking people if they have questions all day. So I guess if you have more questions now, then it would be good. Otherwise, I see that we've reached our 2 hours. What do you think, Daniel? Should we try to stick to the time?
So I guess that's a good time for the official end. But if anybody wishes to stay and chat, then we can. But I guess it is a good time if Theodore, if you wish to say goodbye for the YouTube people, and then we can continue discussing.
So I guess that finalizes the official part. What's going to happen now is that the YouTube recording is shut off. And as the final part of the video, I would like to say a huge thanks to Tommi, both for writing Malli and explaining it. Yeah. So thanks a lot.
Thanks for having me. It was fun.